Hello, this is Mr. Stansbury. I'm going to take you through some of the problems on the 11A Part 1 assignment. First one we're going to take a look at here is 2C. Find the equation of the tangent to this function when x is -1. Okay, so we need three things. We need the x-coordinate, the y-coordinate, and the slope. So those are the three things that we got to find. Okay, so good news is we already have the x. Okay, so we want to have the x equals, y equals, slope equals. X we already know equals -1. If we want to know what the y equals, we just plug the x into the original equation here. So we get y equals 3 times -1 to the -1st. So officially that's going to be 1 over -1 to the first power, so that's still just going to be -1. So we get y equals 3 times -1, which is -3. Okay, and then to get the slope of the tangent, we got to take the derivative. Okay, so we're going to take this here, y equals 3x to the -1st, and now we're going to find the derivative. -1 times 3 is -3. X to the -1 times -1, sorry, -1 plus -1 is -2. So there's our derivative function. So to find our slope, this -1 is going to go in for this x here. So we get y prime equals -3 times -1 to the -2nd power. So that's really 1 over -1 squared. So -1 squared is just going to turn into 1 over 1. So our y prime is just simply going to be -3, which is going to be our slope. Okay, so now that we have all of those, we can now plug it into our point slope formula. So we do y minus, our y1 is -3, so it's minus -3 equals m, which is -3 times x minus -1. So those double negatives turn into a positive. So to those, we get y plus 3 equals, distribute the -3 through, we get -3x minus 3. Subtract 3 from both sides, and we get that y equals -3x minus 6. That is the equation of the tangent to this function at x equals -1. Okay. For this one here, same idea. We need to find our x1, our y1, and our slope. Right? Obviously, that's x1 and y1, but you get the idea. So our x1 there is 2. To figure out what our y1 is, let's plug it in. So we get y equals x, which is 2. Minus 2 times 2 squared plus 3. So 2 squared is 4 times -2 is -8. So that's 5 minus 8, so we get y equals -3. And then now we got to find the derivative so we can find the slope of that tangent. So let's bring this down here. Y equals x minus 2x squared plus 3. That's officially x to the first, right? So 1 times 1 here is 1. Subtract the 1, and those x's are gone, so that's just simply a 1 right there. 2 times -2 is -4, excuse me, and then 2 minus 1, that's going to be x to the first, and then the derivative of any constant is 0, so that's gone. So there's our derivative function. So to find our slope at that when x is positive 2, we're going to simply plug this 2 in for that x right there. So we get 1 minus 4 times positive 2 is 1 minus 8. So our derivative function here, when x equals 2, we get -7. So that's our slope. Okay, and now we plug it into our point slope formula. Okay, so we do y minus -3 equals m, which is 7, all times x minus 2 for the x there. So this is y plus 3 equals negative 7 times x is negative 7x. Negative 7 times negative 2 is positive 14. Subtract 3 from both sides, and we get y equals negative 7x plus 11 for this, the equation of the tangent to this function when x is 2. Okay, moving on to the next one here. We got number 3. Consider the quadratic function. Find f prime of x. So find our derivative. So f prime of x equals 2 times negative 1 is negative 2x. Subtract 1 from that, and that's x to the first, right? So we'll just leave it as x. And then 1 times 6 is 6. And that's really a 1 minus 1, so that x is gone. So it's just plus 6, and the derivative of the constant is 0. So there's our derivative function. B, hence find the value of x for which f prime of x equals 0. So we want to know when f prime of x equals 0, not when x equals 0, but when f prime of x equals 0. So this 0 here is going to go in right there. So that means when does 0 equal negative 2x plus 6? Subtract 6 from both sides, and we get negative 2x equals negative 6. Divide both sides by negative 2, and we get that x is 3. So the value of x when the derivative function, when the slope is 0, basically, that's like a turning point. So we know that there's a turning point when x equals 3. And turning point we haven't covered yet. We're going to cover in a little bit later on in this chapter. That's basically when it's like a minimum or a maximum. Okay, so that's what that's going to be. Anyway, part C, explain the geometric significance of the point where f prime of x equals 0. Oops, kind of let the cat out of the bag there. When f prime of x equals 0, that's the slope equals 0. So again, that means it's going to be a minimum or a maximum. So just to kind of show you what we're talking about, we're just going to graph this original function here. And when we graph that, there's our function. Oops, can't quite see what's going on up there, so let's just do this. We're going to change our window. We want to see it a little bit higher up, so we want our y max to be bigger, so let's turn that into 20. And then we hit graph again. And now we should be able to see what happens at the top there. There we go. And guess what? When x is 3, 1, 2, 3, it's right there at that top point there. And then we can show that also by doing second trace, and we can put in value, and we want to know when x equals 3. So when x equals 3, y equals 13. But the important part is look, that's right there at the very top. So that means that tangent line there is going to have a slope of 0. Okay, so the geometric significance of the point where f prime of x equals 0, it's going to be like a maximum or a minimum on that graph. Okay. All right. The tangent to y equals 2x cubed plus kx squared minus 3 at the point where x equals 2 has a slope of 4. Find k. So they're saying the tangent here at x equals 2 has a slope of 4. So since we've got the slope of the tangent, we want to do the derivative. Even though we've got this k in here, it's going to be all right. So let's do our derivative. Y prime equals 3 times 2 is 6. Subtract 1 from that, and that's 6x squared. 2 times k is 2k. Subtract 1 from that, and that's just x to the first. And then that negative 3 is gone. Okay? So there's our derivative function. And then we know when x equals 2, the slope has to be 4. So this 4 here is going to go in on this side. So it's going to be 4 equals. And then we know that x equals 2. So we're going to go 6 times 2 squared plus 2k times 2. And look, we just have one variable in there, so we should be able to solve for that. So 2 squared is 4 times 6 is 24. Plus 2 times 2 is 4k. So let's subtract 24 from both sides. and we get negative 20 equals 4k. We divide by 4 both sides, and we get k equals negative 5. Okay, so yeah, that one looks tricky, but we just do the derivative and plug stuff in and solve it, and away we go. Okay, one last one to take a look at here is number 7. Consider the function x squared plus 4 over x squared. Find f prime of x. Okay, so a, we have f of x equals x squared plus 4 over x squared. We want to move this x squared to the top so we can take the derivative. So let's do that first. So f of x, we're not doing the derivative yet. X squared equals, let's see, x squared plus 4. Now the x squared moves to the top and turns into 4x to the negative second. Okay, and then that becomes a lot easier to take the derivative of. So now we can take the derivative of f prime of x equals 2 times 1 is 2, subtract 1, so that's just 2x. Negative 2 times 4 is negative 8x, subtract 1, and that's to the negative third. So there's our derivative. Okay, find the values of x at which the tangent to the curve is horizontal. So if the tangent is horizontal, that means the slope has got to equal 0 is what they're getting at. So they're basically saying, when is this equation here going to equal 0? Okay, so let's do that. 0 equals 2x minus 8. Let's even do this, say, over x to the third. Okay, I'm going to do this. I'm going to just move this. I'm going to add 8 over x cubed to both sides. So then we end up getting 8 over x cubed equals 2x. And just to make it a little nicer, I'm going to put 2x over 1. Okay, and then we can do cross products, which is going to be a little crazy, but that's like, you know what, we'll make it work. So 8 times 1, that one's okay, that's just 8. And then x cubed times 2x. There's officially 1x cubed, so 1 times 2 is 2. X cubed times x to the first is x to the fourth. Divide both sides by 2, and we get 4 equals x to the fourth. So now we just simply got to take the fourth root of both sides. So we can bust out our calculator here. 4. I'm going to do math. And then I'm going to do number 5. That's the x root. So it's giving me the fourth root of 4. And it gives me 1.414, which basically means that, excuse me, x is the square root of 2. But it's plus or minus because it's an even power here. So plus or minus the square root of 2 is what x is going to equal for b. That's a little tricky, but we can do that. So let's see, that was B. And then for part C, show that the tangents at these points are the same line. Well, you know what? Probably the easiest way to do that is to plug it into our graph. Let's take a look. Okay. There's our function. And let's see, let's do zoom standard because we changed our window a little bit earlier. Let's see if it fits. Yeah, there we go. There's our two, let's see, the tangents, right, when the slope is 0. So that's this line right here. Yep. Okay, so looks like it's at what, 1, 2, 3, about 4. So it just to kind of help out to show you, if we put in the line equals 4 here, and we put that graph, there's our two. There's the tangent line to both of those 2 points. So it says show that they're the same line. So look, there we go. Those are the same line. Okie dokie. All right. That's all we have for 11A Part 1. If you have any further questions, please feel free to ask. Thanks.